Okay, today I'm continuing with exercise 14.1. Okay, the concept, right, for our next two questions I'm going to do 8c and 11 goes like this. The first derivative of a function gives us the gradient. I will discuss more of this with activity in class, but for now we just take it that the first derivative of a function gives us the gradient. We will understand this in class at a later time. Okay. First and foremost, right, calculate the gradient of the curve. Okay, for 8c, today I'm going to do 8c. Okay, they say that we are to calculate the gradient of the curve at the point where y is given. And the curve is given to be y equals to x squared plus 4 over x. Okay, before we can even do anything, what we have to do is simplify the equation. So I get x squared over x plus 4 over x. If I were to simplify further, I get x plus 4x to the power of -1. Simple enough for now. Okay, this part here. Then what happens here is this. Okay, first, okay, from here, this part here, I will say I will let y equals to 5. Why is y equals to 5? Is because that's the given value there where you say y equals to 5. So I say 5 is equals to x squared plus 4 over x. Then we are doing this because we want to find the x value. You'll see why I need the x value later. So I get 5x equals to x squared plus 4. Okay, x squared minus 5x plus 4 is equals to 0. Now I get x minus 4, x minus 1 is equals to 0, x equals to 4, or x equals to 1. Okay, this is not the end of the question. All I've achieved here so far is that when y is 5, I have found the corresponding values of x. Now, we carry on with the meat and bones. Okay, as I've said above, the first derivative of a function gives us the gradient. So, from this portion here, okay, let me draw it out in pink pen. Oopsie. Okay, I will get y equals to x plus 4x power -1. So first thing I want to do is I am going to differentiate. Okay, I'm going to differentiate my function y, okay, with respect to x. So here, x, if you differentiate, you get 1. Okay, minus 4x minus to the power -2. So I simplify dy dx is equals to 1 minus 4 over x squared. Okay, as I said, this is my first derivative. I have differentiated y once. My first derivative gives me the gradient. How do I find the value of the gradient? Okay, so far you notice I got a value of x and x here. So I'll say this. Dy dx, if I substitute in the value of x equals to 4, I get 1 minus 4 over 4 square. So what I'll get is 1 minus 4 1/4. 4 over 16 is 1/4. So my gradient when y equals to 5, then x equals to 4 is 3/4, like this. Then also my gradient, okay, I have x equals to 1. Okay, I get 1 minus 4 over 1 square. So my gradient is also -3. So notice that when y equals to 5, okay, my gradient of the graph can either be 3/4 or -3. Okay, now to better help you understand the solutions here, 3/4 and -3 is just calculations. I'm going to use Graphmatica to show you what I've actually done. Okay, so now I'll exit the screen, okay, and I will go to Graphmatica. Okay, this is Graphmatica. So I've keyed in the equation down here, x squared plus 4 over x for question 8c we've just done. Okay, so this is, if you follow the cursor, is I key y equals to x squared plus 4 over x, and this is the resulting graph down here. Okay, so I'll use calculus and I'll say find the draw tangent. So this graph, okay, this tool will help me to find the gradient at different points. So just now we know that y equals to 5, which is down here. Okay, so now I try to find, notice that when y equals to 5, there are two x values. X is equals to 1 or x is equals to 4, okay, which we have found earlier. So what I do here, I find for x equals to 4 first. Okay, they have drawn a tangent there. The tangent line will give me the gradient of the graph at this point. I draw your attention to the bottom part of the screen now, bottom left. Notice that they say draw tangent at x equals to 4, y equals to 5. The slope is 0.75, okay, and 0.75 is what we have gotten earlier there, okay, 3/4 down here. So we have found the first gradient. Now again I use calculus 2, then I draw a tangent. The other point when y equals to 5, my x value is 1. Down here they have drawn a tangent to the graph at this point. I draw attention to the bottom left again. Notice that when x is 1, y equals to 5, they draw the slope or the gradient at this point is -3. I go back to the answer we have. You notice just now we have calculated that the gradient at that point is -3. So in this case, by calculation, we can find that when y is equals to 5, I have my x values, okay. When y equals to 5 over here, okay, my x value is 1, or my x value is equals to 4. If I draw the tangents at these 2 points, I find that my gradients are 3/4 and -3. And I've used Graphmatica to help me to explain further on calculating the gradient using the first derivative.